All right, we're going to pick up where we left off. We're at problem number 21. Problem 21 is asking for the zeros of the function f of x equals x squared plus 7x plus 5. Now this is a quadratic function. The zeros of the function are the same as the solutions to the equation x squared plus 7x plus 5 equals 0, because you're looking for the x values that when you plug them in make all of this equal to 0. So the solutions to the quadratic equation and the zeros to the function are the same. So I'm going to solve this. Now this does not factor, and you can kind of tell that it doesn't factor because if you look at the choices, you have a multiple choice problem. The answers involve radicals, and of course that's usually a tip-off that it's not going to factor, because I don't see anybody factoring with radicals. So I'm going to use the quadratic formula. X is equal to the opposite of b plus or minus the square root of b squared minus 4ac, and that's all over 2a. So I'm going to identify a as 1, b is 7, c is 5. And I'm going to substitute these in. I'm going to get x is equal to the opposite of b. So that would be a negative 7 plus or minus the square root of b squared minus 4ac would be 7 squared minus 4 times 1 times 5. It's nice that those are all positive numbers, so you don't have to worry so much about the signs, all over 2 times 1. So this is negative 7 plus or minus the square root of 49 minus, now what I like to do here is I like to cover up everything to the right, or cover up everything to the left of these three numbers so I can just see what I'm subtracting. I'm multiplying 4 times 1 times 5. This comes in handy when there's negatives involved here as well so that I don't mess up on my signs here, but that's 20, so I am subtracting 20, and that's all over 2. So that's going to be x is equal to negative 7 plus or minus the square root of 29, and that's all over 2. And I don't think that's going to simplify because the square root of 29 doesn't simplify. And I'm going to see if I match an answer, and that looks a whole lot like answer D. All right, let's skip to the next problem. Which of the following represents the graph of the equation below? And here's your equation here. Y equals the opposite of x squared plus 2. Now this is also a quadratic function in that you can see that the variable x is being squared. Notice that a is negative. A is a negative 1. That means graphically that your graph opens downward. Remember, if a is positive, it opens upward. If a is positive, it opens upward. If a is negative, it opens downward. So this is going to tell me it opens downward. Well, that eliminates two of my choices right off the bat. And my vertex here, if you want to do the opposite of b over 2a, since b is 0, there's no x term, you can see that the x value is going to be 0, and the y value, if you plug 0 in for x, is going to be 2. So I look at my two choices here. This has a vertex at 0, 2. This has a vertex at 2, 0. This is the guy I want. I want answer B. I could do that without having to do very much more than just identify what A was and then look at where my vertex is, because these graphs were different enough that I could tell. Now, if I go to problem number 23, in problem number 23, it says, what are the real zeros of the function of the graph? Now, this kind of a function here would have this kind of a graph. But when it's talking about the real zeros using the graph, what they're saying is, when does it equal 0? Well, it equals 0 on the x-axis. When does f of x, when does the function equal 0? Those are going to be my roots. As I was showing you back here, you would set it equal to 0 to find the zeros of the function, to find the roots of the equation. There's no equation given. All we have is the graph. But the key is the x-intercepts. The x-intercepts have a y value of 0. And as you can see over here, I have two x-intercepts. Let me grab the actual problem here so I can see which answer it matches up with. And let's see. I have, this is a 1 here. I don't know if you can see that very well. 2, 3. This is a 0, negative 1. I have x-intercepts at x equal negative 1 and at x equal 3. Now don't be faked out by this negative 6 down here. That's when the x is equal to 0, not when the y is equal to 0. So which answer does this match? This looks like this matches answer C. Look for the x-intercepts when they're talking about finding the roots given a graph. Now in problem 24 it says, does the parabola y equal negative 2x, negative 2 times the quantity x minus 4 quantity squared plus 1, does this guy right here contain a maximum or a minimum point, and if so, what's the maximum or minimum value of y? Well, Notice here that this is in vertex form. Vertex form looks something like this. Okay, where your vertex is hk. H, now notice it's in the form x minus the number, x minus 4, and then there's a plus k on the end. So it's kind of the opposite of what it looks like inside, exactly what it looks like outside. A here is the same A I was talking about back here when I was trying to decide, does it open upward or downward? Well, my A here is -2, which is less than 0. So that means the graph is inverted. It opens downward, which means that the vertex is up at the top of the hill. That means it's a maximum, okay? So it says, does it have a maximum or minimum point? It has a maximum point. Well, that eliminates, if I'm remembering right, 2 of the choices for the multiple choice. And now you need to know the vertex, because it's the k value of the vertex that gives you your max or min point. Well, in this case, this form right here, you can see h is 4 and k is 1. Your vertex is 4, 1. So that means the 1 is your maximum value. That means this point here is 4, 1, and it's not going to have any y values bigger than that 1 because the graph goes downward. All the y values are going to get smaller. So that is choice, let's see here. Did I write it down? That looks like that is choice D. All right. 2 more. Pedro throws a ball upward at a rate of 20 meters per second from an initial height of 2 meters. The height of the ball above the ground can be approximated by h equals -5t squared plus 20t plus 2, where t represents the amount of time in seconds. So he throws the ball up in the air from an initial height of 2 meters, about 6 feet off the ground, at 20 meters a second. It says, since the ball has been, the t represents the amount of time in seconds since the ball has been released. What is the maximum height that the ball reaches? Again, look at this, it's quadratic. H equals -5t squared plus 20t plus 2. This is a quadratic function, and notice A is negative. That means the graph of it, just like the last example, opens downward. I'm going to have a maximum value, but where's my maximum value at? It's at the vertex. But I don't have this in vertex form. I have this in standard form. That's where I use x is equal to the, or in this case, let me change that a little bit. T is equal to the opposite of b over 2a. In this problem, a is -5 and b is 20. I can find the first coordinate of the vertex here, the kind of like the h back here, by using this little formula right here and substituting these numbers in, -5 in for a, 20 in for b. I hope I left myself enough space here. This is -20 all over 2 times -5. -20 over -10 is +2. So 2 seconds after the ball leaves this Pedro's hand, it peaks. It reaches its maximum height, pauses for an instant, and then drops back down. But what's that height? This is when, this isn't how high it is. They want the maximum height. They want h. So you've got to plug 2 back in here and find the height that goes with it. So my height is equal to -5 times 2 squared plus 20 times 2 plus 2. Now remember, you square before you multiply. Don't multiply these two numbers together. Order of operations, exponents first. So this is going to be -5 times 4 plus 20 times 2 plus 2. This is -20 plus 40 plus 2, which is 22. So this thing reaches a height of 22 meters. Don't forget your units. And hopefully that matches an answer. It does. It matches answer D. This is a good kind of a problem. You're going to see this in Algebra 2, you're going to see this in pre-calculus, and you're even going to see this in calculus. Alright, the next guy up. They give you a table of values, t and v of t, where it says some quadratic function, call it v. We want to know which one of these choices do these points, or do these values best fit. So my suggestion is, rather than trying to create the equation, you've got, since it's multiple choice, work backward. Don't necessarily take the first one, don't necessarily take the last one, take one in the middle. Let's say I take this guy right here. I'm going to look at this for 1, 6. I'm going to plug 1 in for t, and I'm going to see if v is 6. Now, let's start with a. If I plug 1 in, I get 4 minus 1 squared. That's not 6. If I plug 1 in, here and here, I get 1 squared plus 2 times 1 plus 1. That's 4. That's no good. If I plug 1 in, I get 1 squared minus 2 times 1 plus 1. That's 0. Well, looks like it better be answer D, but I'm going to plug it in to make sure. If I plug 1 in here and here, I have 1 squared plus 3 times 1 plus 2. Yep, that's 6, and that's my answer. All right, we'll do some more problems here in the next video.